optical in generalized. Okay, so in the microwave, we have seen there is a two type of devices. One is active device and another one is passive device. The first part we're going to see all the passive component. Okay, so this is the prescribed textbook for your microwave. That is first two thing. That is T1 is nothing but your textbook, and R2 is nothing but your reference. Similarly, T2 is nothing but your textbook. Okay, so the first two thing is for your microwave engineering, and Kaiser is for your optical communication. So these three textbook has to be followed. Okay, so all these three I will upload into your Google Classroom also for your reference. But Annapurna Das is not that much required, but in microwave sample Leo itself, everything will be get covered. Okay, so in last class we have seen about the spectrum and coaxial connector. Okay, coaxial cable connector we have seen. So just we have seen the what is the connector model and what are the basic model types we have seen. I will just show how in real we are using. Okay, then since everything we are talking in real component, and if anyone waiting outside, please let me know, students, so that I will give admit options. Can you able to see? 1 minute, I will pass it. Can you able to see this video? Can you able to see this video, students?
Yes, sir.
Yes, sir.
Yeah, just look into it. Yeah, please see this thing. There is a two thing is there. One is the spectrometer. This is nothing but the cursor where I am moving is the spectrometer. This is the slotted line section. But the main thing is this is your coaxial cable. So which I am showing in the cursor. This is your coaxial cable which connects together, and we are finding the some measurements. Just to see this small video. Yeah, please see. So actually, in real, we are not calculating this type of calculations, but you see, in behind these type of normal calculations are there. So from the user to the base station, some inclination will be there. Basically, 45-degree minimum. Okay, this is the minimal distance x. Right triangle is there. Okay, so through that, some applying Pythagoras theorem, and we can find the unknown data. Okay, this is normal calculation for finding the how much the intensity level, minimum intensity level, up to maximum intensity level also we can able to calculate. Okay, so for connecting your coaxial cable between any of your device, the where base station is the one there have antennas, but we deal with the microwave gadgets. Okay, there we have the some coaxial cable. You can see this is nothing but your we have completed the first part, the waveguide. Okay, so something like isolator, circulator, or T devices. You can see some rectangular opening is there, and some holes are there. So through this hole only we will use some screws and to connect it, and you can have some slot to connect to this device, and so we can find what is the spectrum in the real time application. That is the main objective of this coax cable. Okay, so the main objective of this coaxial connector is that to connect with any of your microwave gadget to find out the polarization measurement. So whether it may be horizontal or vertical polarization, and it can be done. That is, it can be find out with the various measurement calculations. Okay, so this is what there are different types of the connector. You can see the terminal side. You can see different shapes and different materials will be there. So through that we can find out the unknown measurement. Okay, so like this. So these things for a minute. Okay, so these are the connectors we have studied. Yeah, so these are the connectors we have studied and some specification details we have said here. Okay, so those things alone, just look into it for your examination purpose. Okay, so in last class, these are the ones we have studied. Adapters also we have studied, and the waveguide sections we have seen in the last class, and the waveguide show. Okay. So in today's section, okay, so we not repeat the same thing. Just to recap, I am told whatever we have seen in this thing, and we also completed the short circuit plunger. So this is the main setup which is available in your water pump. Okay, I will show how this mechanism also works. So in real, so in the same principle only, it allows the signal in the waveguide. Okay, so I will just show this animation also. The same. Okay. So you see this thing also. Okay, so here some that is pumping lead will be there. When we are pressing this, according to this brush unit will be come to left and right, and according to that the pressure is going equally on upside and the downside, so that it will be released. Will be released the signal accordingly to this waveguide gap. Okay, so through that only our signal is going inside. Okay, just to see this small mechanism. So this is the main unit in your this device. Plunger will be there. Yeah, please see that thing. It is going left and right. So you can have some gaps there. So accordingly, the pressure unit will go in and out. Okay. So this is the basic mechanism of your plunger unit. Okay, the short circuit plunger. Okay, so the plunger unit is made up of, here is the copper material. You can have the quarter wavelength of this vernier calipering scale. Okay, to provide the bandwidth of 20 to 30 percentage. Okay, 20 to 30 percentage. So you can see another thing also, the plunger with the double plunger unit is there. Okay, double plunger unit is there. The best example for this is the gun. So everyone see the gun. This is the one real thing. Okay, so when we are loading the bullets inside, and we are just setting up. Okay, this type of setup has been there in your real gun. Okay, I will just show this thing also. You can get a clear idea of this short circuit plunger. Okay, the short circuit plunger unit will be there in all gadgets. So this is one of the best example I am. Once it loaded, okay, yeah. So please see, after loading the bullet in the gun, they are pushing up. Okay, so there, this part inside you can have the spring unit and the plunger unit will be there. So once they trigger it, okay, so it will take one bullet. Okay, just to see this one mechanism. Yes. Yes. So in this way only the it will be emits out that bullet. Okay. So only that emission thing alone go forward. That is that cover has been will go in opposite direction. Okay. So this is the best example for this short circuit plunger. It is also available in water pump and also used in the where it is used in the gun. Okay. So next is the waveguide. As of now, we have completed all waveguides, but there are different types of waveguides are there. As per the cross sections we have seen, we have studied only the rectangular waveguide. Okay, rectangular waveguide. So the next is shape is like circular, elliptical is also available. Okay, so mostly this type of waveguide you can see the cross-sectional view alone I have shown. So in this way only the radiation will come from the input side to the output side. So it contains both electric and magnetic spectrum. Both are transverse with each other. Okay, so here the two color actually in naked eye we cannot able to see. So the best example is your mobile phone. So when you talk continuously, what happens? Some heat energy on the surface will be there. So that is called as the ohmic loss. Through that ohmic loss only we are experiencing some heat energy is on the surface, and we will leave it. Okay, so this is the basic shapes of the waveguide. Okay, so rectangular. So based on this, we can calculate the modes, different types of the modes. So there are different modes are there. One I will show in the next PPT. When we talk about the mode, there are many modes are there, but we particularly for communication, we will talk only the dominant mode. So everyone know what is the meaning of the dominant. The dominant is the one we are dominant with any other or any of the parameter. So that is called as the dominant. Okay. But among the various modes, which one is the dominant? Let me see. Okay, so the based on the wave propagate on the this type of waveguide only, we going to calculate the what is the electric and magnetic field with respect to the time. So we will find what is the cutoff frequency first of all, and we will find what is the lowest cutoff frequency. The mode with the lowest cutoff frequency is the dominant mode. Suppose I am sending the spectrum of signal. Actually, you are doing in EMF lab in Sonet. Okay, when you creating the what different calculations like VSWR calculation, return loss, S matrix, power, okay, and Z naught, etc., etc. What is your x-axis? X-axis is your frequency. Correct. So under analysis, you will set up some frequency range. Okay, some frequency range between some starting frequency and the stopping frequency, and you will mention what is the step size of that frequency. So in that, which is the lowermost value is called as the lower cutoff frequency. For lower cutoff frequency only, we can know that whether the signal comes from your device or not. So that point is nothing but the dominant mode. Okay. So there are different types of mode. There are basically three types. One is transverse electric, transverse magnetic, and transverse electromagnetic. Okay, transverse electric, transverse magnetic, transverse electromagnetic. So you can see the condition, the definitions also for each thing. The electric field is purely transverse. Okay, the electric field is purely transverse to the direction of the propagation. Suppose I am say this is the direction of the propagation, then my that is the field component of electric field is perpendicular to it. Okay, similarly, if my magnetic field is in this direction, then magnetic field, sorry, the axis is in this direction, then the magnetic field will be perpendicular. So you can see in these two conditions, if electric field and say, then there is no magnetic field will be there. Please see the transverse electric field, H is not equal to 0. That means magnetic field only exists. Okay, magnetic field only exists where electric field equal to 0. If transverse magnetic field, if I say electric field will exist, that is it not if Ez is not equal to 0. If I am say both are electric and that is transverse and electromagnetic, then both has no field, that is Ez and Hz equal to 0. Okay, you can see at dominant mode in this direction only goes, only in 2-dimensional. So at that condition, the condition has been given like this, TE10. So you may know that how what is the basic digital logic. Okay, so like this. Um, so they have mentioned like 10 suffix. You can see it is mentioned like 10. Basically, what are all the modes will be there. Okay, so like TE. I will run it and write it immediately. Yeah, it will be. Okay, it will be like TE00 mode, TE01 mode, TM00 mode. Sorry, not T. I have wrongly written. That is TE00, TE01, and TE01. 10 and TE11. So there are four possible conditions are there. Similarly, for TM also TM00, TM01, TM10, TM11. Similarly, TEM also 00, 01, 10, 11. So in all the modes, okay, that is TE, TM and TEM. Okay, so that is TE10 mode is the dominant. You may ask question that why TE10 mode is the dominant. You can see this is your rectangular slab. So it is L and B. Okay, L and B. So where L is very greater than that of B. Where L is greater than that of B. So if I say L is a logic of 1, then definitely the B should be logic of 0 only. So this condition will satisfy at this condition among these two values. So 0 is equal to 0 only. 0 is less than 1. 1 is greater than 0. 1 is equal to 1. So only at this case it will be satisfied for rectangular waveguide. Okay, it is a rectangular waveguide. If I am saying my waveguide structure is in circle, my waveguide structure is a circle, then can you anyone tell that which mode will get satisfied for that? Can tell quickly. If my waveguide structure is uh, like a cylinder, on both sides is a circle is there, then which mode will get satisfied? So definitely the radius, please see the radius will be equal. Okay, will be equal in all sides. Okay, so then TE11, TM11, TEM11. Okay, so this is the circle concept. Okay, that is the radii or diameter will be equal. Okay. So when we talk about this thing, we are talking about the what is the one cycle along the dimension A, and what is the number of cycle along the short dimension B. So then the cutoff frequency will be calculated like this. It is the critical wavelength divided by 2. Okay. And what are all the matrices we can able to calculate by using the waveguide. So one is the cutoff frequency, cutoff wavelength, phase velocity, dominant mode, guided wavelength. So let me see each and every one in one by one. Okay, so first is phase velocity. The phase velocity is not a real velocity. Apparent velocity of wave along wall used for calculating the wavelength in guide. Okay. So what they are telling is that phase velocity is that when the signal is going inside the waveguide, okay. So some progressive phase shift will be added along with your original signal. Okay, so we can able to calculate the what is your impedance matching. Okay, impedance matching, that is Vp is equal to T divided by whole root of 1 minus Fc divided by F2 the whole square. Okay, so this is nothing but your phase velocity. Similarly, the guided wavelength. What is the guided wavelength? From the word itself, you can understand mostly this waveguide is used to guiding or protecting your signal. If I am having the guided wavelength, then I can protect the signal is flowing inside that medium. Okay, so if the value of your guided wavelength is good, then there is stability as, but that is a proper stability has been maintained in your system. Okay, so this is the basic specifications of this thing. One is the design should be accurate and it contains the high efficiency then a low attenuation, directivity is high and able to carry the high frequency. Okay, so this is the basic requirement or specifications for your the given passive component. Okay, so this is the another device called isolator. For this, I have given one justification that a person is isolated himself during this pandemic. That is the typical meaning of the word isolation. Where isolator also like that, it will allows only unidirectional, not allows the other directional. Only one directional alone. Once we connect to your microwave setup, it can be used entirely. So if you change the direction of this port, then some progressive phase shift will be added. Okay. Okay. So this is your isolator, and this is your vernier caliper scale setup. So you can see in the picture what I have told. Only in energy flow diagram for the isolator, it allows only in single direction. So you can see the three important point has been given. One is it is a minimum attenuation. Since if I'm tell one basic example, a person is going in one of the shop, but he found that there is no queue. Okay, there is no queue. So then what do? The people will proudly stand, and the person also mislead that for which person the item has to given. Okay, he itself confused. Similarly, another shop is there. He allows the person in queue. So queue means what happened? So once the person is go one by one, he has to be give in other side. So only in one direction alone he will forwarding and allowing outside in other direction. Okay. So this device is also called as the uniline, used for frequency stability. Okay. So this is the basic introductory of the isolation. You can see this is the isolator. In isolator, from the word itself, you can understand it is a two-port device. And if it is the two-port device, then what is your S matrix size? It is a 2 cross 2 matrix. There is a 4 element you will get. So this type of device is a lossy device, they will tell, since it not allows the signal in other direction. Okay. So when there is a signal, okay, so there is the it cannot allows the standing wave ratio. So what is the standing wave ratio? Once the signal is going inside, it will add with your reflection coefficient also. But you can see in this animation how the signaling is going. Okay, so it is rotate with the help of the Faraday rotator. Okay, in this device, in your curriculum also you have used the Faraday rotation in your textbook. They not use the resonance absorption and the field isolator. Okay, some basic things alone they have given with the help of the Faraday rotation. Okay, so this is called as the isolate. So in isolator, basically we should know about how the Faraday works. Okay, so this is the construction diagram. Okay, so I have drawn the Faraday rotator. Okay, so very good signaling effect when it goes inside to the resistive vein. So you can see this is the opening of your waveguide. So near to it itself, the resistive vein should be there, but the vernier caliper setup. Okay, vernier caliper setup is available in your resistive vein. So when it rotates, okay, it will shows the degree. Okay, it will allows the degree. Um, then it will, for each iterations, your magnetic rod, you can see at middle, you can find the magnetic rod, it will rotate one time. This is continuous process, and it not stop once it has been initiated. Okay, so based on this Faraday rotator only, this has been progressively changed with the polarization. Basically, the polarization, just remember, it is the nothing but the orientation of your electric field. Okay, suppose I am saying that my polarization input polarization direction is like this, but my output polarization direction is like this. Please see, when I'm mapping together, okay, so the remaining bandwidth of the signal will get transmitted in your waveguide, it get wasted. So when I am either input or the output side, I map with this thing, then output is uh, yeah, once it will be synced with that thing, then the maximum signaling will be transferred. Okay, so this is the one of the best example of it. So you can see the some apps. Okay, so you can show your innovativeness, students. I have mentioned some of the app. Everyone accessing mobile phone and then laptops. Okay, so go to the Play Store and you can find some apps. But some app is your textbook. But I am not interested in the textbook. You can take any one of the app which have some of the experiments. Basically, waveguide, the first part of your unit. Just to try to do some of the uh, work in that app, and please take snap, and you can submit in the assignment link. Okay, I will provide the assignment link, and I will mention what is the deadline for the assignment link also by today end class. Okay, can you use any microwave engineering app? Okay, I have mentioned some few things only. Okay, so you can see these three I have mentioned it up. One is the microwave engineering. In the Play Store, you can go and you can get. This is your textbook. You can see this is one of the textbook, but this is not required. You can see this is the another microwave engineering app. It can able to measure the microwave insertion, attenuation, VSWR, crystal detector, etc., etc. So once you click on, and you can give the matrices whichever you have calculated. Okay, calculated, uh, and based on it we can work out.